With weeks to go until THEGAME Developers Conference kicks off in San Francisco, it's time to start finalizing your schedule. If you are still paging through the session SCHEDULALOOKING for hidden gems, good news, a number of DD 2019 speakers have taken the time to make 60-second-ish pitch videos for their talks, and you can watch them right now on the official GDC YouTube channel. Produced for the 4th year running, these flash-forward videos are always great encapsulations of what makes DD talks great. They are fun, lovable, and informative. Each is a personalized PITCHFORY. You should make time in your busy schedule to check out a given talk while you are attending BD. We have once again no GDC 2019 flash-forward pitches into a playlist embedded below, and added more information about each speaker, and a link to their talk in the description of their video. Have a look. You can find this and lots more great videos over on the official GDC YouTube channel, which is also regularly updated with new talks, according to GDC through the ages. Subscribe, and you will be the first to know about when new videos are added to the channel. For more details on these speakers, talks, and many more, head over to GDC 2019 session scheduler. There you can begin to lay out your GDC 2019, which takes place March 18th through the 22nd at the newly renovated Moscone Center in San Francisco. Bring your team to GDC. Register a group of 10 or more and save 10% on conference passes. Learn more. For more details on GDC 2019, visit the show's official website, or subscribe to regular updates via Facebook, Twitter, OS. Gamasutra and GDC are sibling organizations under parent company Informa. At Niantic, we are in the process of developing an incredible planet-scale augmented reality our platform, designed to help would-be game developers quickly and easily create their games without having to solve a lot of daunting technical challenges. We created the Niantic Real World platform as the technological embodiment of our core ideas: exercise, exploration, and social interaction. These principles manifest as a set of Java server libraries and client Unity C.Key APIs on mobile clients, and this technology underpins the core server and client engines of Ingress, Pokemon Go, and soon Harry Potter, Wizards Unite, as well as other future products. In December, we announced the Niantic Beyond Reality Developer Contest, and invited developers to join us in developing incredible experiences on the Niantic Real World platform. Before we release it to everyone, we had previously previewed VR mapping and computer vision portions of our platform in June. Since then, many teams have asked us what our platform can help them achieve, and to paint a broader vision of what is possible with a successful application of our technology. In this post, we explore where we believe our experiences are heading and the tech stack we have built in anticipation of that trajectory. For the sake of explanation, let's briefly leap ahead to a world of ubiquitous wearable computing. In this world, future art devices seamlessly blend all of our senses between the real and the virtual worlds. Our everyday experiences at play, work, and social are enhanced by hardware that is unobtrusive, can go anywhere, and is connected in real time with low latency 5G connections. What kind of experiences would you build for this future? First of all, we expect this future to be inherently shared and social. At Niantic, we have seen how playing together has made an enormous impact in engagement in our games. Other players tell us that besides having fun, they have found benefits in making friends and building communities. In this future, sharing our experiences would enhance these benefits. To do so, our interaction has to be natural to our senses. The digital would obey similar rules to the physical in order to create the suspense of disbelief in our brains. When this balance is achieved, players are immersed in this magic realism where they can have frictionless fun. Check out Codename Neon, one of our prototypes that was created to demo this. The technology just works as expected, obeying laws of physics. For example, players in Codename Neon can harvest energy from the white pellets on the ground, and those are shared resources, so if one player gets them, the other players cannot. Second, when do you expect the world of art to be heterogeneous, reflecting the variety, beauty, and diversity of the planet we live on? Natural in when do you be incentivized to explore the real and virtual worlds together, and the data used to create virtual experiences should be tightly coupled to the real world. For example, in Pokemon Go, when it rains in a player's location in the real world, that is reflected in the game, sensory experiences should align. Because in doing so, we are driven to discover this brand new world of art in a way that is connected and meaningful. Third, when you expect those virtual worlds push us to exercise and move, capitalizing on our own natural rhythms of motion and rest. We can create compelling experiences that invite us to move and ensure that the VR and geospatial experiences unfold at an intentional pace. For example, Codename Neon has a first-of-its-kind game mechanic that encourages players to move at the scale of large open spaces, like parks, rather than a tabletop scale. Also in Ingress and Pokemon Go, kilometers walked is a mode resource that opens up many possibilities in incentivizing players to explore their neighborhoods or cities. What technology did we build to satisfy these ideals? In order for our experiences to exist in a single virtual world, we need to be able to take a single instance, real-time geospatially queryable environment to a massive scale, and allow for the creation and mutation of shared geospatial objects. As a result, the central part of our platform is a real-time geospatial storage, indexing, and serving engine, which manages worldwide geospatial objects that developers can control. However, because we envisioned a world where a single world on games that integrate and tie everyone's reality together need to operate on a massive scale, with monthly usage measured in the billions of users. A major part of the technological investment we made was in horizontal scalability while retaining a single world instance, primarily by rethinking how several authoritative games could be conducted on top of horizontally scalable Kubernetes container technology in conjunction with NoSQL denormalized data stores, rather than on the single instance, relational SQL databases that most, in the past, were typically built on. Consequently, Pokemon Go is built entirely on this platform, and has demonstrated concurrent real-time usage of several million players in a single, consistent game environment, with demonstrated monthly usage in the hundreds of millions. Additionally, during our initial development of Ingress, we found that it was infeasible to create a game world that seemed real and concrete using procedurally generated on-script content. Doing so would create a sense of cognitive dissonance whereby the game would highlight locations that were algorithmically sensible, but in reality were insipid. As a result, we rely on our comprehensive data set of millions of the world's most interesting and accessible places to play our games that are nearly all user-generated, along with the toolchain to load and select displays is based on metadata criteria into game titles. This dataset has been constantly submitted, curated and updated over the past 6 years by our players. As such, this dataset is critical to enabling experiences built on our platform, to inspire users to explore their real world and walk from place to place. These features are managed with a set of mobile client-side Unity APIs that map to a high-performance native solution that enables the performance rendering and stylization of both real-world map information, as well as geospatial game objects. We have found that the most non-intuitive parts of the game to code, that also consequently can have the most impact on serving scalability and client performance, is maintaining the real-time linkage between player location and the state of the game world around them. As a result, we focused our efforts on creating an intuitive API that handles the intricacies of querying and caching both map and geospatial objects as the player moves about the world, allowing developers to code a planet-scale, single-instance, real-time multiplayer gameplay with these, and thereby freeing up opportunities to focus on finding the fun in their game designs. Finally, we created a comprehensive set of APIs for real-time multiplayer experiences using the phone as a control device and viewing portal into the virtual world. We have focused on solving the hard problems in computer vision, networking, and game prototyping tools to make sure developers focus on the experience building. Our technology optimizes for real-time that achieves peer-to-peer multiplayer latencies that are in the tens of milliseconds. To put this in perspective, with rendering at 60 FPS,